All right, here's the last density problem we're going to do. An element from another universe with a molecular weight of 145 grams per mole, an atomic radius of 1.25 angstroms, was found to crystallize in a face-centered unit cell. Calculate this novel element's density. All right, so what do we know about this at least? It's face-centered, which means which formula are we going to use? Face-centered, hopefully we're starting to memorize this by now, is this one right here. This is face-centered. And we're asked to calculate the density. And we know the molecular weight is 145. Molecular weight's 145 grams per mole. And the radius, I think it gave us, is 1.25 angstroms. All right. So this is going to be, the density is 4 atoms, because it's face-centered, times the atomic mass, which is 145 grams per mole, divided by 6.022 times 10 to the 23rd atoms per mole, okay? All divided by, and it's going to be, remember how I was able to multiply or at least distribute this exponent over, because we have a 2 to the 3 halves here with a cubed exponent, it's going to be 2 to the 9 halves, and then that's going to be times the radius cubed, all right? So this is going to be the radius 1.25 angstroms. Now in centimeters, that's going to be, hopefully we're starting to get that also, it's going to be 1.25 times 10 to the minus 8 centimeters cubed. And then I just multiply all this out and I should get density. And atoms cancel here, per mole cancels here, and I should be left with grams per cubic centimeter. So let's go ahead and multiply this out. It's going to be 4 times 145 divided by the quantity 6.022 times 10 to the 23rd divided by the quantity, this is going to be 2 to the 9 halves power, and then also divided by the quantity 1.25 times 10 to the minus 8, and that whole thing is cubed, and I'm getting this has a density of 21.79 grams per cubic centimeter. Now for this problem, I know I said in previous videos, if you get a density that's this high, you might want to go back and check, but I pretty much just made up this problem, so I didn't know exactly what to expect. All right, so this one is not necessarily in any way accurate, but hopefully it gives you some intuition how to calculate density. You're pretty much with these formulas doing the same thing every time. You're given everything but one, every factor but one, and you're solving for that factor. So they either don't give you density or they don't give you the radius. And pretty much that's every problem. You're solving for either the density or the radius, and then you just have to figure out which one of these equations to use, and that's pretty much every density problem. All right, so hopefully that gave you some intuition on how to calculate densities. Make sure to like this video and subscribe to the channel for future videos and notifications. Thank you very much.